I'm going to talk about prime factorization. So prime factorization is where we take a number and we break it down into a product of just prime numbers. So on the screen you see two factor trees for 24. On the left we have one that starts with 2 times 12. Anytime we have a prime factor, we bring it straight down, and anytime we have a composite number, we break it down farther or further, and it doesn't matter how we do it. So the next row after 2 times 12 becomes 2 times 2 times 6, as an example. We bring down the primes, and we break down 6, and we get 2 times 2 times 2 times 3. This is the prime factorization for 24. It doesn't matter how we do it. If we start differently, like on the right, we might start with 3 times 8. And the 3 gets brought down, and 8 becomes 2 times 4. And the 3 gets brought down again, and the 2 gets brought down, and the 4 becomes 2 times 2. And we land at the same thing, 3 times 2 times 2 times 2. Order does not matter. So the fundamental theorem of arithmetic states that all numbers can be written in one and only one way as the product of primes. This is an amazing thing. It is I think of it as a number's fingerprint. It tells everything about that number. It identifies that number uniquely, and it shows all the numbers that go into it. So for example, we can see from 24's prime factorization that 2 goes into it, and 3 goes into it, and 4 goes into it because 2 times 2, and no 5. 5 is prime, it would have to show up. And 6 goes into it, 2 times 3. No 7. 8 goes into it, 2 times 2 times 2. No 9, that would be 3 times 3. No 10, no 11, and finally 12, 2 times 2 times 3. We can X-ray all numbers using their prime factorization.